Long before modern power grids, wireless communication, and advanced electronics, Nikola Tesla was experimenting with ways to control and transmit electrical energy in ways that few people fully understood. Some of his ideas became the foundation of the electrical systems we rely on today. Others were tested, documented, and then slowly faded from public attention. Over time, many of these experiments were simplified, misunderstood, or surrounded by speculation. But behind the myths and rumors, Tesla carried out a series of real energy experiments that were both ambitious and technically interesting. Understanding these experiments helps explain how electrical engineering evolved and why Tesla's work continues to attract interest even today. Nikola Tesla lived during a period when electricity was still a relatively new technology. Engineers were trying to determine how electrical energy could be generated, transmitted, and controlled in practical ways. At the time, there were no large-scale electrical grids, no standardized systems for distributing power, and very little understanding of how electrical fields could be used for communication or energy transfer. Tesla approached these challenges with a different perspective than many of his contemporaries. Instead of focusing only on improving existing machines, he spent much of his time exploring how electrical energy behaved under unusual conditions. He experimented with high frequencies, high voltages, and resonant electrical systems. Many of these experiments were conducted in laboratories where Tesla built large coils, transformers, and oscillating electrical circuits. One of his most well-known experimental devices was the Tesla coil. A Tesla coil is a resonant transformer that can generate extremely high voltages at high frequencies. Tesla used these devices to study how electrical energy moves through space and how electromagnetic fields behave when driven at certain resonant frequencies. These experiments allowed Tesla to produce long electrical discharges and observe how energy could move through air and other materials. While these demonstrations often looked dramatic, they were not simply visual experiments. Tesla was studying the relationship between electric fields, magnetic fields, and resonance. Another important area of Tesla's research involved wireless energy transmission. Tesla believed that electrical energy might be transmitted through the atmosphere or the Earth itself if the correct resonant conditions were created. To explore this idea, he built large experimental transmitters designed to generate powerful oscillating electrical signals. His most famous project related to this concept was the Wardenclyffe Tower. The tower was designed as a large experimental system intended to test global wireless communication and possibly wireless energy transmission. Although the project was never completed due to financial difficulties, the research involved in the project helped push forward the development of radio technology and long-distance wireless communication. Tesla also carried out experiments involving resonance in electrical systems. Resonance occurs when an electrical system naturally oscillates at a specific frequency. When energy is applied at that frequency, the system can store and transfer energy very efficiently. Tesla believed that resonance could be used not only for communication but also for transmitting energy across distances. Today, resonance is widely used in many technologies: radio transmitters, antennas, wireless charging devices, and many electronic circuits depend on resonant electrical behavior. Although Tesla's large-scale vision of wireless power networks was never implemented, the underlying principles he studied remain central to modern electronics. Another lesser-known aspect of Tesla's experiments involved high-frequency electrical currents. At the time, most electrical systems operated at relatively low frequencies. Tesla explored what happened when electricity was pushed to much higher frequencies than those used in normal power systems. These high-frequency experiments led to new insights about how electrical energy interacts with materials and how electromagnetic waves propagate through space. Many of these discoveries contributed indirectly to the development of radio communication and early wireless technologies. Tesla also experimented with unusual coil designs and electrical configurations. For example, he patented the bifilar coil, a design where two wires are wound together in a way that increases the electrical potential between adjacent turns. This design allowed the coil to store energy in both magnetic and electric fields more efficiently. Although the concept may sound complex, it simply shows how changing the physical structure of an electrical component can influence how energy behaves within it. This idea is now common in modern electrical engineering. Engineers often design components carefully to control how energy flows through circuits. Over time, some of Tesla's experimental projects were overshadowed by the rapid development of commercial electrical technologies. As power companies built large electrical grids and communication systems evolved, many experimental research programs were replaced by standardized industrial designs. Because of this shift, Some of Tesla's laboratory experiments became historical curiosities rather than active engineering projects. However, they were never truly forgotten. Scientists, engineers, and hobbyists still study Tesla's experiments to better understand the principles he was exploring. The reason is simple. Tesla was investigating how electromagnetic systems behave at their limits. When you study extreme conditions such as high voltage, resonance, or high frequency, you often discover new ways to control energy. Modern technology continues to explore similar ideas: wireless charging systems, advanced power electronics, and high-frequency communication networks all rely on principles related to Tesla's experiments. The real lesson from Tesla's forgotten energy experiments is not that they were magical or mysterious. It is that they were part of a long process of scientific exploration. Tesla was testing how electrical energy interacts with fields, materials, and space itself. Some experiments produced immediate practical results. Others simply expanded our understanding of electromagnetic behavior. Both outcomes are valuable in science. Every modern electrical system from power plants to smartphones depends on a deep understanding of electromagnetic fields, and many of those concepts were explored during the early experiments carried out by inventors like Tesla. So when people talk about Tesla's forgotten energy experiments, they are often referring to research that was simply ahead of its time. The experiments themselves were real, carefully documented, and part of the scientific process of discovery. Understanding them helps place Tesla's work in a clearer context. That he was not trying to create mysterious devices or impossible energy systems. That he was trying to understand how electricity behaves in complex environments. And that curiosity continues to drive modern engineering today. If you found this explanation useful, consider subscribing to the channel. New videos explore practical electrical concepts, experimental energy ideas, and the history behind technologies that shaped modern power systems. And if you want to explore how some of these experimental electrical concepts connect to small energy systems and practical setups, there is a useful reference linked in the description that outlines the main components people often review when studying generator-based energy systems and similar projects.